Hey guys, just to let you know, this lesson is in collaboration with Flip Academy, a free online platform for all of your GCSE, A-level, IB and CBSE revision, out now on web at www.flip.academy, and also as an app for Apple, iOS and Android. It really is better than all the other GCSE platforms out there. It covers all the topics in great depth and has an app that you can download your courses on and use offline. To Flip Academy, today we're going to be looking at the algebra topic for the AQA specification. And what we're going to start off with is some of the fundamentals of algebra. So this is one of the spec points. What you need to be able to do is look at and interpret algebraic notation. So for example, the fact that instead of writing A times B, we generally just write AB. Okay, so the same thing as if we had like 3 times x, we would just write that as 3x. So we don't tend to write the multiply signs. Instead of having something similar to this, instead of writing y plus y plus y, we can just group that together as 3y. And also, instead of doing, for example, b times b, we instead write b squared, okay, where 2 is just the number of copies of multiply that we have. And we also have something like, instead of writing a divided by b, we tend to write that as a fraction in algebra, just to keep things nice and compact. There are 2 more things that you should remember, and they're fairly self-explanatory. So we tend to not write decimals, so 0.5x is not usually written. You should also be able to write it as a fraction. Now both of them are correct. It's completely fine whichever one you use, but you need to recognize that you can use both. And lastly, you need to recognize the fact that we can use brackets in algebra. So for example, 2 times 4 plus x, and what that means. We're going to get on to exactly what that means in a second. So the next thing that you need to be aware of is substituting values into expressions, okay? And remember, an expression just means you have a bunch of algebra terms, but you have no equal signs, okay? So with an expression, there's just no equals. Okay? So in this case, if f is 7, g is 5, all you need to do is find where f is and replace it with the number 5 and do the same thing with g. Now this is where we have to use brackets, because instead of writing 37, that's incorrect. You need to write 3, open bracket 7, plus 2, open bracket 5. And again, the reason for that is when we write 3f, we mean 3 times f. And now you replace it, so 3 times 7. Okay? So 3 times 7 gives me 21. 2 times 5 gives me 10. 21 plus 10 is equal to 31. And that's a quick 2 marks, okay? And again, c equals 4d minus 7. So find the value of c when d equals 6. So that's just the other way that they can word it. So either an expression or as an actual equation. And all you need to do here is, once again, instead of d, we're writing the number 6. So 4 multiplied by 6 minus 7. So 4 times 6 is 24. Minus 7 would give me 17. Again, for another 2 marks. Next thing we need to do is we need to go through a certain vocabulary. So we actually covered some already, so it's nice and easy. So, for example, let's go through some of these. We have expressions, which we went through just now. And again, keep in mind that they tend not to ask you specifically to define these words, but you need to be able to recognize them. So they may say something like, circle the expression. So an expression is simply a collection of terms with no equal signs. So you should keep in mind that when we have a collection of terms, there's usually operators. Okay? And an operator is simply add, subtract, divide, or times. So this brings me on to what the next word is, which is a term. A term is just either a number or letter or both. So what I mean by that is the number 4 is a term. The letter B is a term, but also the letter or the combination 3x is a term. So if I were to write something like this, 4 plus b plus 3x, we have three separate terms, 4b and 3x. And this is an expression because there's no equal signs. It's a collection of terms. It has operators in between it and no equal sign. So that is a definition of an expression. The next thing you need to work out is, or need to know, is an equation. Very easy. An expression with an equal sign. So again, that should be fairly simple. If we use our previous example, this is the expression, and if we press, or just use equals, so it could be equals 0 or anything else, that is now an equation. You also need to know what inequalities are. It's simply the greater than, less than, greater than equal to, less than equal to, or the not equal to signs. Those are your inequalities, and you need to be able to use these to create expressions and equations and things like that. Lastly, a factor. It's just a number. And again, if you're unsure, go back to the numbers video that we did, and I'll also go into more detail about what factors are and how you can work them out. A number that divides into another number with no remainder. And that's it for the vocabulary section. It's not too bad. And again, it's very unlikely they'll ask you to literally define them, but you need to be able to recognize them and use these words when you're talking or writing your answers. Next, we have simplifying expressions. So this is using things like the rules of indices, expanding brackets, and factorization. So, rules of indices, let's go. So, a to the power of b multiplied by a to the power of c, all you do is you add the powers. Okay, so for example, x squared times x cubed is equal to x to the power of 2 plus 3, so it's equal to x to the power of 5. Fairly easy. A to the power of b divided by a to the power of c, and remember in algebra we can also write this as a to the power of b over a to the power of c, so keep that in mind. Just gives you a to the power of b minus c. So again, if you want to do an example, x to the power of 5 over just x would give me x to the power of 5 minus 1. Remember, if we just have x, it's like there's an invisible 1 there, and that will give us x to the power of 4. Next we have a to the power of b, and then close bracket to the power of c, and all this equals is a to the power of b times c. So if you had something like x squared all cubed, then you'd have x to the power of 2 times 3, which is 6, and there you have it. The last one is one that's a bit tricky. So a to the power of minus 1 just gives you 1 over a. So that might not seem too tricky in and of itself, but they can have things like, for example, 3 over 4 to the power of minus 1. That would give you 4 over 3. Or they can have something like a to the power of minus 3. That now becomes 1 over a cubed. The minus makes it 1 over. Okay? Expanding brackets, this shouldn't be too difficult. And again, there is expanding quadratics or expanding linear. We're going to just do linear for now. So if you have a bracket like this, you should know that the number outside the bracket multiplies every number or everything, every term inside the bracket. So 3 times x, that's 3x, because remember we don't write the times sign. 3 times positive 2 gives me positive 6, nice and easy. And then we have factorizing, so this is where it gets a bit more interesting. So we've worked out how to expand the brackets, now we need to work out how to put them back into brackets. So let's say we have something like 4x plus 8. What I need to ask myself is, what is the biggest thing I can take out of 4 and 8? So what is the biggest factor? Well, they're both in the 2 times table, okay. but they're also both in the 4 times table. So I write 4 on the outside, that's my highest common factor. Then I open bracket and I divide both of these things by 4. 4x divided by 4 will give me x, because remember we don't write the 1. 8 divided by 4 would give me 2. And now if you notice, if I expand this out again, and this is the great thing about factorizing, is you can always check your answers. If you expand it out again, you should get the same thing as the question. 4 times x is 4x. 4 times 2 is 8. Since the first and last things are the same, we are all good to go. And that will cover that spec point. So I picked a couple of questions from past papers just to kind of show you some other things that they can ask you to do. So obviously it's not as simple as it can be. This type of factorizing, it's a quadratic, but if you notice, it's the difference of 2 squares. So the way you know this is if you have x squared and it's subtracting a square number, okay, it's minusing any square number, you can write this as the square root of that number. So in this case, the square root of 64. That's x plus 8, x minus 8. So it'd be this value. So for example, and again, if you want to expand this out, you can see if it's correct. So x squared minus 4. 4 is a square number, right? So I'm going to write my 2 brackets. And what's the square root of 4? Well, it's plus 4 and it's minus 4. That's it. So that's called the difference of 2 squares. And again, with the expanding brackets, sometimes it's not as easy as just expanding a linear bracket. Sometimes you have a quadratic or cubic, so something like this. So hopefully you should know that all you need to do is pick 2 of the brackets. So I like to keep the first bracket the same for now. And now I'm just going to expand the second bracket. When you're expanding quadratics, you need to remember FOIL, which is first, outside, inside, and last. So what that means is I times the first 2 things together, which is x and x. If you remember, x times x, we add the powers. So 1 and 1, x squared. Outside, I times the outside thing, so x times by 5, which is 5x. Inside, so that's the inside bits, 2 and x is 2x. And last, the last 2 terms, 2 and 5 is 10. So you might notice that each of these things so everything in the first bracket times is everything in the second bracket. The x times is by everything in here, 2 times by everything in here. Now we simplify by gathering any like terms. So x squared, there's only 1 x squared. X's, there are 2 x's terms, 5x and 2x, so 5 plus 2 is 7. And there's only 1 constant term, so plus 10. And then again, there's no real acronym for this one, but we need to make sure that everything in the first bracket times everything in the second bracket. So let's give it a go. So I'm going to first do the x's. X times by x squared gives me x cubed. X times by 7x gives me 7x squared. X times by 10 gives me 10x. Now the inside bit, minus 3 times x squared is minus 3x squared. Minus 3 times 7x would be minus 21x. And minus 3 times 10 is minus 30. And now all that's left to do is, again, simplify. So there's only one law of x cubed. There is 7x squared and minus 3x squared, so that makes 4x squared. There's 10x minus 21x, so that's minus 11x. And then there's just the constant term on the end. And that will be your answer. So 3 marks. I don't think that's too bad. You just need to be very meticulous. So make sure that everything's timesing everything else. And you're good to go. The next really key skill, especially if you're going on to do future maths as well, but also just for your exam, is to rearrange formulas for different subjects. So what they'll do, and again this is a past paper question, 3 marks, pretty good, is they say that y equals 1 over root x plus 1. Now you need to make x the subject. So what they mean by make x the subject is you want to have at the end x equals and then a bunch of stuff. Okay? So this is actually a pretty difficult rearranging question, and I picked it on purpose so we can go through it nice and carefully. So let's rewrite the question. We have 1 over... First things first, if you look at where our x is located, it's on the denominator of a fraction. If this ever happens, you always want to multiply by the denominator of that fraction. And what that will let you do is bring it up. So times both sides by root x plus 1. So that becomes y square root x plus 1 equals, now if you remember rightly, if you times by the denominator of any fraction, it gets rid of the fraction and you're just left with the numerator, so in this case 1. Okay, now what's stopping the x from being by itself? We have this plus 1, the square root and the y, so we work outwards and go in. Let's get rid of the y first because it makes things less complicated, so divide both sides by y, and we get root x plus 1 is equal to 1 over y. Now we need to get rid of the square root, and how do you get rid of square root? Well, you do the inverse, which is squaring. So we square both sides. That gets rid of that square root, and if we square the top and bottom, 1 squared is 1, y squared is y squared. And then lastly, all we need to do is subtract 1 from both sides, and we get x is equal to 1 over y squared minus 1. Okay, and that's 3 marks. Not too bad, but again, it's a bit tricky. Now, this is specifically for higher. There's equivalent expressions and proof. Proof is a very tricky topic. Okay, but what you need to do is learn a few basics and then work from that and really think logically about what they're asking you to do. So, and again, they can ask you about anything, so you can't really memorize all the proofs in the world, because they can just ask you about an infinite number of things. So prove algebraically that the sum of any two consecutive integers, consecutive means next to, is always an odd number. Well, okay, now it's any two, so I'm picking two random numbers, but they're next to each other. So my first number, because I don't know what it is n. Now the number next to it is going to be n plus 1, right? So they're saying the sum of these two integers is always odd. Okay, well n plus 1 gives me 2n plus 1. This is always even, and any even number, so even plus 1, is always equal to an odd number. If I even think about it, right? 2, if I add 1 is 3, it's odd. 4, if I add 1, that's 5, it's odd, and so on. So if you double a number and add 1, it always becomes odd. Therefore, the sum of any two consecutive integers is always an odd number. Okay? Think about it, also makes sense. If these are consecutive, if this is an even number, this would be an odd number. Even plus odd is odd. If this is an odd number, then this is an even number. Odd plus even is also odd. So that makes perfect sense, hopefully. Next one. N is an integer. Prove algebraically that the sum of n, n plus 1, and n plus 1 is always a square number. So again, if you're unsure, just do what they say. The sum of. So sum just means you're adding. Now if I look at this, I can't really prove it's a square number, right? If you remember, a square number is a number that can be square rooted. And gives a whole value, right? Not a long decimal, okay? Or an irrational number. Okay, so what if I expand the brackets? Will that help? Well, n times n, that gives me n squared, plus n, plus n, plus 1. That gives me n squared, plus 2n, plus 1. Okay. Now, can I factorize this? And this is a skill we're actually going to come on to a bit later. But when you factorize, if it's just a n squared at the front, so there's nothing in front, we're looking for two numbers that times to the number on the end, 1, and add to the number in the middle, which is 2. So what are two numbers that times to 1 and add to 2? Well, it's 1 and 1. So that will be n plus 1, n plus 1. Now, if I'm writing the same thing twice and then multiplied in algebra, remember from the first point, a spec point we did, that would just be n plus 1 squared. Has to be a square number. So let me explain why. N is an integer, a whole number. So if I add 1, it's also a whole number still, right? Now if I square it, that answer must be a square number because I can square root it and get an integer, right? If I square root this, I get left with n plus 1, which is an integer. Therefore, this whole thing is a square number. Okay. This one it's a bit more of just a way that you can think about things. So there isn't really any questions specifically on it, but you need to be able to interpret expressions and functions as functions with inputs and outputs. So the idea here is if I have y equals, I should be able to interpret that there are inputs and outputs, right? There are numbers I can put in to get numbers out. So in this equation here, if I sub in a value for x, let's say 2, it will give me a value of y, an output. 2 times 2 is 4, plus 1 will be 5. That's it. Okay? They just expect you to know that there are expressions that you can put numbers into, inputs, and it gives you an output, an answer. Okay? Now, they also expect you to know that if you want the complete opposite, so for example, if we make it a bit easier, right? Fairly standard, input is x, so shoving a number to x, it doubles it and spits it out. If I want to go backwards, instead of timesing by 2, I divide by 2, right? That's just called an inverse function. It's the one where you put back in the outputs and get out the inputs. And then if you were to, for example, get y equals 2x, and then do another function afterwards, so let's say you had z equals 2y, and the idea is that you would sub in a value for x here, get the number y out, and then sub the y back in. That is called a composite function. Again, there aren't really any questions specifically on it, but it is just, you need to be able to interpret that, okay? Okay, this one hopefully is relatively easy. Work with coordinates in all 4 quadrants. So, again, if you have your graph, x and y, right, you have 1, 2, 3, 4, 6. And again, if you're going down here, you should be able to draw these axes exactly as I'm doing it. Right, except obviously very neat with a ruler. And you should be able to work with the coordinates, okay? So, again, that might sound a bit scary, but not too bad. You should be able to say, for example, if you wanted to plot the coordinate 4, 5, you should be able to know that the first number is how far left and right you go. So if it's 4, we're looking for 4 along the x-axis, so that's here. And then 5 is how high up you go. So then you should know that you're looking over here. And likewise, -2, -3 would give you, again, look along the x-axis. -2 is here, down to -3 would be over there. And then, again, -2, 4. Again, you have -2 here, 4 up here. So you should be able to work with coordinates in all of these axes. And then last quadrant, 3, so looking for 3 along, then -2 down. That's it. Okay, so all you need to do is be able to interpret that. Again, the first number is how far you find the first number along the left to right, the x-axis. Then you find the second number, how high up and down you go, and then you can draw the point. Not too bad, hopefully. Plotting straight line graphs. Okay, so this should be relatively okay, but you should be able to, for example, if I give you an equation y equals 2x plus 1, you should be able to pick any range of values and plot them, so x and y. Let's start from -1, sorry, 0, 1, 2, 3, and you should be able to plot the values, so sub it. And again, this is using the substitution we went through in the second spec point. So 2 times -1 is -2, plus 1, -1. That'll be 1, and then so on, right? So you should see it's going up by 2s each time. And you should be able to plot that on an axis like this, but it would be accurate. So that means it would be straight lines. All of the intersections would be kind of 1 mark apart, and that's it. And then finding parallel and perpendicular lines, you should be able to see that M is the gradient of the line, and C is the y-intercept. So the gradient tells you how steep a graph is, whereas the y-intercept tells you where it cuts the y-axis. And with gradients, parallel lines have identical gradients. So what this means is that if you have like y equals 2x plus 1, another parallel line would be y equals 2x plus 2, or y equals 2x, because the number in front of x is the same. Now you need to be careful here, because sometimes they try and prank you a bit, and they'll put like 2y equals 2x plus 4. That's not parallel, because it's not in the form y equals mx plus c. Y needs to be by itself, so you divide through by 2, you get y equals x plus 2, so it's not parallel, okay? Perpendicular lines are a bit more funky. Perpendicular lines, they have a negative reciprocal gradient. So perpendicular they meet at right angles. Okay, and they have a negative reciprocal gradient, so it looks like this. So again, if we say that our gradient was 2, then the perpendicular line will have a gradient of -1/2. That's it. And if the gradient was 4, the perpendicular line would be -1/4. That's it. Flip the sign, 1/, done. Okay, hopefully not too bad. So again, we have some relatively, hopefully okay exam questions. So write down the equation of the line parallel to y equals 3x plus 2. Well, the gradient here is 3. So all I need to do is write an equation, and it doesn't matter, right? That has 3x in it, and then plus any number. So minus 50 billion plus 3, minus 1/2 plus 500,000, doesn't matter. Pick any number, it really doesn't matter, okay? And then likewise, write down the equation of the line that's perpendicular to y equals 3x plus 3, where the gradient is equal to 3. So we need to do -1 that, so it's -1/3. So the gradient is y equals -1/3 x, and then plus any number. Not bad. So we've already actually kind of done this before. So when they say algebraically, they mean using the equation. Can you tell me the gradient and the intercept? Easy, right? Gradient. Intercept. That's it. Okay. Now in terms of graphically, the y-intercept will be where the point P is, and the gradient will be worked out using a calculation which we'll come to shortly. So what is the value of y at P? So basically, what is the y-intercept? It's 5. Write down the equation of another line, which is parallel to this. We've already done this. It's y equals 3x and any number. So bear in mind, where I'm writing any number, you would write an actual number. Okay, like 3, 4, 5, whatever you want to do, okay? So a straight line has an equation y equals 5 minus 3x. So if you want, you can write this in the form y equals mx plus c. by just writing the minus 3x first and then doing the plus 5 like that, okay? You can swap around these terms however you want. The gradient is the number in front of x, which is minus 3. Write down the coordinates of the point where it crosses the y-axis. Well, again, we have the 5, but the x-coordinate is always 0 for a y-intercept. So it crosses the y-axis, that is the y-intercept. And it's always going to have x is always equal to 0. Okay? So if you have a look at where the y-axis is, it's along the line x equals 0. Okay. So now, this is where we get to work out what the actual gradient is. So find the gradient of line L. So I mentioned before you need to be able to do this graphically. So that's why this question's in here. So to do it graphically, there is an equation, which is quite nice, which is the change in y over the change in x. So what I'll do here is, where does y, so when you say change in y, you need to see where it ends up and where it starts. So it ends up at 5, so we're going to do 5. And it started off at minus 5, so minus 5. Or if you used your head, the difference between 5 and minus 5 is 10. Okay? X, it ends up at 2 and starts off at like minus 1.5. So we have 10 over 3.5, right? And you don't have to specify any clearer than that. The other way to do it is to use a big triangle. So if I draw a big triangle here, and I'm picking points that are that touch the corners of the squares. Now what I do is I work out what the height of this triangle is, which is just the difference between minus 4 and 5, which is 9. It's 9 squares high, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. How many across is it? It's 3 across. And then I just divide the height by the width. And that would be 9 over 3, which is 3. Now if you notice, 10 over 3.5 does give you very close to 3. So that's completely fine. Okay? That's why there's a discrepancy here, okay? But yeah, that is how you would do that. Okay, so 2 methods. Draw the triangle, work out the height and the base, and do height divided by the base. Or the change in y over the change in x, whatever you prefer. Again, you can actually choose any 2 points. So you could choose these 2 if you wanted to, and you'd get the same answer, right? So this would be 2 minus 1 over 1 minus 0, which is 3 over 1, which is 3. So it's still the same thing. Okay. This is where things get a bit more interesting. So you need to use completing the square to get turning points. Okay? So a turning point of a graph is the bit where it turns. I know that sounds a bit stupid, but it's either the lowest possible value or the highest, or the peak. Okay, so you know you have 2 different types of quadratic. It could also be like this. So this point, the absolute top or bottom of it, okay? So, to do this, you use completing the square. Okay, now, for completing the square, again, this is a 2021 paper question. Let's do it. So obviously, by the way, with graphically, you literally just read off the coordinates. That's it. Okay? So if this is, let's say, 1 and minus 3, the coordinates of the turning point are just 1 minus 3. That's it. Completing the square is a bit more involved. When you have completing the square, you have something that looks similar to this. And what you do is you change this into x plus b over 2 squared minus b over 2 squared plus c. That looks really complicated, but it's not that bad. Now let's take this expression and do it. So we have y equals x plus b is 14. 14 over 2 is 7. Very advanced maths we're doing. Minus 7 squared plus 52. So y equals x plus 7 squared. 7 squared is 49, so minus 49 plus 52. So y is equal to x plus 7 squared. Minus 49 plus 52 is 3. Whopping, right? So how on earth do we get the coordinates of the turning point? Well, there are actually two ways I like to explain this to people. One way is using your brain, just memorizing. All you do is you flip the sign of this thing and you keep this the same. Okay? Flip what's inside the bracket. So if it's minus, it's plus. If it's plus, it's minus. And just keep that the same. That's all you need to know. Now, for those of you that are a bit more mathematically inclined and you want to know why, what is the smallest thing I can make this equation, right? So let's have a look. If I have x plus 7 squared plus 3, what's the smallest thing I can make it? Well, okay. If this bracket is positive, it's going to be squared, so it becomes bigger, and it adds a positive number. Okay. If it's 0, the smallest value is just 3. Now, if I make this negative, it gets squared and becomes positive again, right? So the smallest value this bracket can be is 0, which only happens when x is the opposite of whatever the number is next to it. That's why you flip the sign. So you flip the sign of this, keep that the same. Because the smallest thing this bracket can be is 0. It can't be negative because you're squaring it. And we have another question which has something very similar to here. So circle the coordinates of the intercept of the line with the y-axis. So again, what some people would do is probably circle, well, in fact, you can't circle it here, -2. But if you have a look, you have a 3 in front. So we need to divide all of this by 3. So 3y divided by 3 is y, equals x minus 2/3. So the y-intercept is minus 2/3. The only one that has minus 2/3 is that. That must be my correct answer. And here we go, write down the roots of this expression. So this is the graphical way of doing it. So the roots are just the solutions. Now if you have a look, this graph, right, here, is this equation. So where does this graph equal 0? It equals 0 here and here. So in other words, at x equals 2 and x equals 5. That easy. Write down the x coordinate of the turning point. Well, the turning point is the bit where it loops off. So let's say it's probably here. So there's 1, 2, 3, 4, 5 indentations between 3 and 4. So it goes up in 0.2s. It's halfway between them. So 2, 4, 5. 3.5 is what I would say is the x coordinate. Cool. Okay, this is where things get a bit more, I mean, I keep saying that it gets easy, or that it's fun or interesting or something like that, but, you know, it's not the most interesting of topics, but I personally quite like graphs, so let's do it. You need to be able to recognize and sketch linear, quadratic, trigonometric graphs. So, linear is a straight line, okay? Hopefully that's fairly obvious. Quadratic, you have two variants. You're going to have either a happy face or you're going to have a sad face. That's it. Now the trig graphs, this is where students get a bit uncomfortable. So, we have three trig graphs. We have sine, cos and tan. Let's start with sine. Sine and cos tend to get confused. Sine starts at 0, goes up like this. And this is 90 degrees. That's 180. That's 270. So all you're doing is adding 90 degrees. So the way I like to remember it is every 90 degrees, something happens, right? So at 0, it's 0. At 90 degrees, it becomes 1. 180 is back down to 0. So all I'm doing is adding and minusing 1 each time, right? So 90 degrees 1, 180 degrees 0, minus, and then 270, etc. Cos looks very similar to this graph, except it's dragged backwards, right? So it looks something like, it starts at 1 and it will go like a big bucket shape. So it's starting off at, oh, also the peak is 1 and the bottom is -1. Same thing for this one. And 90 degrees is 0. So if you like it's out of step. And then 270. And hopefully you can see that it literally is just the sine graph, right? But dragged backwards, right? So it is literally the same thing, okay? Now we have the tan graph, which is the one that causes mild discomfort, I'm going to call it. So let's get some space up here. The tan graph, this is the one that makes students cry. What it is depending on the region they want you to do, sometimes they start it at -90, right? And end it at whatever. And it basically goes up like this, where these values here are asymptotes, which means the graph never touches them. And then all it does is it literally repeats every single 180 degrees. So again, like this, right? And that would be 270 degrees. Okay, so it is literally the exact same thing over and over and over again. Hopefully that makes sense. The last two graphs they can ask you for is the exponential. I actually find that students tend to remember this one pretty well. You have something that starts very small and it ends up really, really big. Or it can start off really, really big and become really, really small. Either way. And lastly, reciprocal graphs. Students tend to not have come across this at all. But essentially it looks like this, where these two axes are asymptotic. Or again, you can actually have it on the other side as well, so flip it around. Whew, okay. So you need to be able to recognize them. So with this graph, k is a constant. Which one is it? Well, if you have a look over here, let me try and get over there. It looks like this part of the reciprocal graph. So it will be, we know it's going to have something over x. So it's going to be that one. Okay. Translations and reflections of graphs. Okay, so this is where things get even more, I want to say, interesting. Translations. So generally speaking, what they'll do is they'll say translate by some amount, or they can say that y is some function, and they'll want you to sketch 2f of x, for example. Okay. So if I get rid of this for 1 second, let's go. If it's outside the bracket, it multiplies y coordinates by a, and if it's inside the bracket, it does the opposite. So divide x coordinates by a, and again if it's outside the bracket, so f of x plus a, you add a to y coords, and if it's inside the bracket, you again do the opposite. So the way I like to remember it is that if it's outside the bracket, it does what it says and it does it to y. If it's inside the bracket, it does the opposite and affects x. And you just need to be able to sketch this. So if we take an example, let's say that y equals f of x, and we have a graph like this, and initially it goes through the origin, and then they want me to sketch f of x plus 2. Remember, this is going to subtract 2 from x. So instead of going through the origin, it's going to slide over to the left, where this is now minus 2 and 0. And that's all you really have to do. Reflections are a bit more tricky. There are a few ways to do it. Some people are able to do it in their heads. But if you're like me and you're not as visual, you'll want to use either a tracing paper or a mirror and place it along the mirror line, okay? So if it's reflected in y equals x, you place the mirror there and draw what you see, okay? And yeah, so we have some more, again, past paper questions to make sure you can see exactly what they applied to. So this is fairly tricky. What they ask you to do is draw the graph of y equals cos x minus 90. So remember, it's going to do the opposite. So plus 90 to x. And they've actually drawn the graph of cos x for you. So if I'm plussing 90 to x, then all I'm doing is moving all of the points over. So instead of this being 1 here, it's going to be 1 over here. Instead of this being 0 at 90, it's going to be 0 at 180. Instead of being... goodness, I forgot that. Instead of being minus 1 at 180, it's going to be minus 1 at 270. And instead of being 0 at 270, it's going to be 0 at 360. So it looks something along the lines of... So we should really start from the beginning, but let's just do it as this for now. You look like that. So as you can see, all I've done is slid it over to the right. And then it says draw the graph of 1 plus cos x. So remember, this is going to... It's outside the bracket, so it's going to plus 1 to y. So here, all it's going to do is drag the whole graph up. So here, y is 1, so now y is 2. Here, y is 0, so now y is 1. Here, y is minus 1, so now it's 0. Here, y is 0, so now it's back to 1. Here, y is 1, so it's 2. And we draw the exact same shape. That's it. If you're a better artist than I am, then you can probably draw it a bit more accurately, but they're not super particular. You don't have to be Van Gogh or anything. Just drag it up a bit, okay? So plot and interpret graphs in real contexts, including exponentials. So here, they like to apply the graphs to real context, as they just say. So for example, the graph shows the height above ground of a toy rocket for 10 seconds. So as you can see, starts off at 4 seconds, goes all the way up, and it starts to come back down, which you can kind of imagine it going up in the air, slowing down, and then coming back down. For how long is the rocket in the air? So most students would just circle 10 seconds because that's where it touches the ground, and they'd be wrong because it leaves the ground at 4 seconds and returns to the ground at 10 seconds. So the actual difference here is 6 seconds. And then using the graph, estimate the speed of the rocket after 6 seconds. State the units of your answer. So if we have a look here, 6 seconds is here. And now in this context, how can we work out speed? Well, speed equals distance over time, which, if I do it here, is going to be the gradient at this point. So the best way to do it is you draw a line that touches, and then you're working out the gradient of this line, and that will give you an estimate for speed. So again, I went to 6 seconds, drew a straight line that touches the curve, work out the gradient, because distance over time is speed. Okay? And that will give you your answer. So calculating, estimating areas under graphs. Okay, so you're expected to be able to either estimate or calculate the areas. Okay, So with the gradients, we've already done that. We've calculated them before, and here we've estimated them. Okay, as soon as we work out the gradient. So how do we do it for areas? Well, if you're lucky, right, you'll get a straight line graph, and you're asked to work out the area under this graph. So all of this space here, that's a big triangle. So if you're lucky, the coordinate here is going to be, let's say, 8, and the coordinate at the top here is going to be 4. And how do you work out the area of a triangle? You do a half, base, which is 8, times the height. So 16. Easy. But we don't deal with just straight line graphs, right? We also have quadratics, you have exponentials. So what you need to be able to do is estimate these areas. The way you do that is you normally just count the squares under it. So if we go back to this example, if I wanted to work out the area under this graph, again, it's an estimate, it's not perfect. One thing you can do is count all of these little squares, and that will be your area. And where you have like half squares here and here, you can join them to make one square, right? Or you could model this as a triangle or a trapezium and work it out that way. But either way, you should be able to make a decent guess at what the area should be. Equation of the circle, okay. Equation of the circle in general is just x squared plus y squared equals r squared, where this is the radius. So, if we get an equation of a circle is x squared plus y squared is 11, don't forget this is the radius squared. So the radius is the square root of 11. So what would the diameter be? Well, diameter is 2 times radius. So in this case, it's 2 square root 11, which is this one. Don't forget, when you do 2 times root 11, it doesn't become root 22. You can't bring them into the surd like that. So that's all you really need to be able to do. It's quite basic at GCSE. Just remember that this is the radius squared. Cool. Solving linear equations. Honestly, this should be relatively okay, but let's as a recap. When you solve, you get the letter by itself. So what's stopping the letter from being by itself? Well, it's the 4, minus 4 from both sides, x equals 15, life is good. Okay? You should also be able to use a graph to find those solutions. Now, solving quadratics. This is a big, beefy part of your spec. It's incredibly common, comes up all of the time, multiple times I would say, in multiple questions, sometimes just like this, or sometimes as part of a bigger question, okay? So, you need to be able to use factorization, completing the square, quadratic formula, and if you have a look, I have 3, well I do have 3, but the other one's off screen, 3 different equations, because we're going to use all 3. So, let's do factorization first. So again, number that times to 10 and adds to minus 7, well that would be minus 5 and minus 2. So if we put that into brackets, we have x minus 5, x minus 2 equals 0. And the solutions, super easy. Both of these brackets need to be 0. So I either have x minus 5 equals 0 or x minus 2 equals 0. So plus 5, x is equal to 5, or x is equal to 2. Easy peasy lemon squeezy. Now, some students, by the way, ask me, how do I know when to use factorization completing the square or quadratic formula? Well, if you can factorize it. But how do you know, right? Like for example, this question, hard to tell if you can immediately factorize it, right? So, look at this. 2 decimal places. If it says this, you do the quadratic formula. That's it. Quadratic formula is x is equal to minus b plus minus square root. See? Over 2a, where a is the number in front of x squared, b is the number in front of x, see is this number. So for our answer here, it's going to be minus, and always use brackets, please. There are sixth formers that don't use brackets and they get the wrong answer for a variety of reasons. But if you just use brackets, it will stop that from happening. So you may be asking, how do you put the plus minus into your calculator? You don't, you do one at a time. So if I get my calculator up, all we do, sub it exactly as I've written it. Do the plus first. Doesn't actually matter, you can do either. Three. And write this down to, again, if it's not in decimal places, just change it, 4.30. And then all you need to do is go back and change it. You don't have to enter the whole thing again. So you don't need to enter the whole thing again. Just go back and use the arrow keys to change the answer. 0.697, so 0.70. So again, if you notice, we're actually always getting 2 answers for our questions so far. And then for the last one, we're going to do the completing the square. Okay, so completing the square. So it specifies by completing the square. The other thing it could say is if it just specifies third form, it's a good hint. Okay, but usually they will just tell you. So again, with completing the square, we put a bracket. We half the number in front of x, so 5 squared minus 5 squared minus 3. So x plus 5 squared minus 25 minus 3, 0. Okay, so you can get to this stage, and now what we need to do is solve it. Well, all we need to do is move the 28 to the other side. Square root both sides. And remember, it needs to be plus or minus, because when you square a number, it can be positive or negative. Subtract 5 from both sides, and we get minus 5 plus or minus the square root of 28. And that'll be it. Okay, so it's not too bad with completing the square. It's relatively easy. That'll be it. So here we're going to be solving simultaneous equations. So you can either linear, quadratic, or even using a graph. So there are a few different methods that you can do. One method is elimination, so where you make either the x's or the y's the same in both expressions and then add or subtract them. Or you can substitute. So if 2y is equal to 4x minus 7, times this by 2, we get 4y equals 8x minus 14. Now we can put that 4y right where that one is. So 2x plus 8x minus 14 equals minus 9. Gather the x's, we have 10x minus 14 equals minus 9. Plus 14 to both sides, we get 10x equals, now in that case it would be 5. So minus 9 plus 14 would be 5. So x is equal to 5 over 10, or a half. Now if we sub it back into this equation up here, we get 2y equals 4 times a half minus 7. Scroll down a little bit. So 2y equals 4 times a half, so half of 4 is 2, minus 7. 2y equals minus 5, divide by 2, y equals minus 5 over 2. Cool, so those are our 2 answers. Put big boxes around them just to make sure the examiner can see it. We're done. For higher only, you have iteration. Comes in a few different flavours, but one of them is like an applied question where it's saying the number of rabbits in a field is pt and p0, so this is the starting value. And then each time you go up, it's going to be 1.15 pt. Okay. So we want to work out basically p1, p2, and p3. Now, the way I like to do this, and it's fairly simple, is I like to use the ANS button. This ANS button here. This button stores your previous answer. Okay? So let's say I did 2 plus 2, 4. Okay, cool. So if I did answer times 2, you should get 8. Now if I press it again, it's now 16 because it's doing 8 times 2, and now it's doing 32 and 64 and so on. So what I like to do is I take the initial value, and again this works for both types of iteration questions. You take whatever 0 is, press equals. So now the ANS button is that value. And this is exactly what you type. You enter this expression into your calculator exactly as it is, okay? And you replace the variable bit with the ANS button. So 1.15 ANS minus 20. Now every time you press equals, you'll get the next one along. So P1 equals gives you 230. Now what other people have to do is now rewrite the whole thing but with 230. But since we're geniuses, press equals again, we get the next value, 241.5. Okay. And we can just keep pressing equals and get our value. And that tells me 254.725, right? Now, I don't know much about rabbits, but you can't have 0.725 of a rabbit, I'm pretty sure. So we're just going to round that up to 255 rabbits, right? And that will be our answer. It's that easy. So again, 3 marks, and you can do this in literally about 10 seconds, because all you're doing is clicking the equals button on your calculator 3 times. Okay? So be very aware of that. And again, this is the other type of iteration question where they give you something that looks a bit ugly. Okay? But again, we're doing the exact same thing. x1, x2, x3, okay? And again, we're going to do this in about 10 seconds. Okay? But because I'm explaining it, it'll take a bit longer. Okay? So we take our 0 value, which is 3. So 3 equals, it's now the ANS button, okay? Now I write this exactly as it is, but instead of the variable, we put the answer button. So 3 plus 9 over ANS squared. So I just press equals, I get 4. Okay. And then I press equals again, I get 3.5625. And again, if you imagine, if you're using a calculator in your exam, you can do this a lot faster than I'm doing it, because I have to click using a mouse. So 3.0914127.4. That's it. That's all iteration is. This is as complicated as it gets, and you get 3 marks. And you do it in about 10 seconds. It's a really good way to... So you're meant to do a mark a minute for your exam, right? So if you can do 3 marks in about 10 seconds, you basically save 3 minutes you can use on more difficult questions, okay? Super easy, super lightweight. Just make sure you're entering it in correctly into your calculator, and then you're letting the calculator do all the heavy lifting, okay? Pretty advanced stuff. So translate situations and procedures into algebraic expressions, and then being able to solve them and interpret the solutions. So here, the lengths of the sides are this. Write down an expression in terms of x for the perimeter. Okay, this shouldn't be too bad, hopefully. So how do you work out the perimeter of a triangle? Well, all you do is you add up all the sides, right? So all I'm going to do is add up all the sides. So we have 3x minus 5 plus x plus 1 plus 2x minus 1. Now, funnily enough, because the question doesn't specify that you need to simplify, you can leave it like this. However, I would strongly recommend against it, because you're going to be solving it in part B. Part A is always making the equation, part B is always solving it. So you may as well just simplify it now. 3x plus x plus 2x, that's 6x. So get rid of these. Minus 5 plus 1 is minus 4. Minus 1 again is minus 5. So we have 6x minus 5. Easy. There you go. Perimeter is 31. Work out the value of x. So what they're telling us is our expression that for the perimeter is equal to 31. Work out x plus 5 to both sides. Divide both sides by 6. And you get x equals 6. And don't forget to write the units. Okay, when they say interpret solutions, this is what they mean. Is it a length? Is it an area? A volume? Who knows? Put the units to tell them what you mean, okay? Solving linear inequalities and also quadratic inequalities if you're higher tier. Okay, so how do we solve that? Well, we solve it in the same way that we would solve this. So if you're ever unsure, just ignore the inequality for now. Okay? Now let's solve it. Well, we need to factorize this, right? So looking for a number that two numbers that times to 3, add to 4. That's 3 and 1. So x plus 3, x plus 1. And we're going to say equals 0 for now, but in quotes, right? So we either have x plus 3 equals 0 or x plus 1 equals 0. Okay. And that would be x equals minus 3, x equals minus 1. So now we need to actually make the inequality again. Okay. So if you imagine the graph, it's going to look something along the lines of this, where this is minus 3 and that's minus 1. I know it doesn't look like that on my graph. In fact, there you go. Minus 1. And we're looking for the values that it's above 0. So we're looking for all of these values here. These values here. So now we need to add the inequality back in. And that's the key thing. You need to draw this because some students would just write, but that's not correct here. Because look, it's not between these values because we're looking for greater than 0. It's above the x-axis. It's actually x is less than minus 3 or x is greater than minus 1. And that's all you have to do. So essentially you can get all of the marks for just solving the quadratic. Yeah, just doing this bit. So if this is probably a 4-mark question, you get 3 marks for doing this, 1 mark for that. So at least solve the quadratic and you'll get 75% of the marks. That's pretty good. Okay. Some other things I might ask you to do is just show the inequality x is greater than minus 3. So what you do here is you find minus 3, draw a circle. If it's equal to, you would colour in this circle. In this case, it's not equal to, so I'm not colouring in. And since it's greater than, we're looking for values above minus 3. We're going to draw an arrow going all the way along. And you have to put an arrowhead because it goes on forever. Yeah? Because it's just above minus 3. That's an infinite number of numbers, okay? Then tells me that y is between 1 and 5, but not including 5. Write down all the possible values. Well, it equals 1. So we can start off at 1, then 2, then 3, then 4. But it doesn't equal 5. So you drop a mark for every value you miss or include that isn't meant to be on there. And lastly, you can solve this. Again, you solve it in the same way you would solve this. Okay? So minus 7 from both sides, we get 40 less than equal to 12. Divide by 4. You get t is less than equal to 3. That's your answer. Yeah, not too bad, hopefully. You need to be able to do different types of sequences. Okay, so we have a few examples of this here. So geometric progression is when it's times by the same number over and over again. Okay, so what you do here is, with a geometric progression, all you're doing is that it's going to be some number times by it, right? So each time it's going to times by a certain number. So what you'd normally do is you'd divide the two terms next to it. But you can't do that because it skips a term. So you do 16 over 4 is 4. So you know that to get there is times by 4. But don't forget, you need to do it in 2 steps. So you divide that by 2, and your term-to-term sequence is 2. So to get here, we divide by 2. To get here, we times by 2, and we get 8. Not bad. First, in terms of the arithmetic sequence are shown. P, 5p. So as you can see, each time they're adding 4p. So to get to this next one, you add 4p, which would be 9p. The sum of the first 3 terms is 90. Find the value of p. So p plus 5p plus 9p is equal to 90. On this side, we have 15p equals 90. So p equals 90 over 15. Okay, which is 6. Okay, nice and easy. In terms of these other sequences that they can tell you, like a Fibonacci sequence, they will tell you if it's a Fibonacci sequence. Okay, and all you have to do for a Fibonacci is you add previous 2 terms. So for example, it normally starts off with 1 and 1. To get the next term, we add the previous 2. So 1 add 1 is 2. 2 add 1 is 3. 3 add 2 is 5. 5 add 3 is 8. 8 add 5 is 13, and so on. But they will tell you if it's a Fibonacci sequence, and normally they tell you how to work out a Fibonacci sequence. Square numbers, you should hopefully know. The square numbers will be 1, 4, 9, 16, going on. Cube numbers, very similar, be 1, 8, 27, and so on. Hopefully that's okay, so let me label that square. And then cube. Deduce expressions for linear and quadratic sequences, okay. So they do break this down quite well for you, I find, in the questions. So you have something similar to this. Again, this is the 2021 paper. First 2 terms are 10 and 17. Here's some information. So the first difference is 7, the next one is 13. So this next term is going to be 30. And we don't know what the next one is yet, but that doesn't, well, we do actually. It's going to be 19, so 49. So we need to deduce or work out an expression for the nth term. So, since it's quadratic, it's going to look something like this. Now, A is always half second difference. So in this case, it's always it's going to be half of 6, which is 3. So now we have 3n squared plus bn plus c. And the way I like to do it is basically use simultaneous equations, right? When n equals 1, I know that the answer is 10. So in other words, I have 3 times 1 squared plus b times 1, so b plus c, equals 10. Okay? So subtract that from the other side, you get b plus c equals 7. And when n equals 2, I have 3 times 2 squared plus 2b plus c equals 17. So again, if I subtract that to the other side, 2 squared is 4, 4 times 3 is 12, so 2b plus c equals 5. All I need to do here is if I label these like that, you can use simultaneous equations. So I would like to use elimination here, because if I do 2 minus 1, 2b minus b gives me b, c minus c is 0, 5 minus 7 is minus 2, and then I can just sub this back in to this expression here, and I get minus 2 plus c equals 7, so c equals 9. So my answer is 3n squared minus 2b, that's 9. And you can always check it by, sorry, not 2b, 2n. You can always check it by subbing in n equals 1, into this. So 3 times 1 is 3, minus 2 is 1, plus 9 is indeed 10. So I'm right. Cool. And that finally brings us to the end of the algebra section. So really well done for getting this far. If you're ever unsure, then go back and check out the other videos for the individual topics.